So there's a reason I put this particular photo. So basically, I feel that more than everything, like all the job opportunities and like all the education, the knowledge and technical skills you learn from ENTC, like I feel what ENTC is more of a home. So where the most important thing you get from there are the people, right? So that's one of the reasons I chose the department. So because I felt like you couldn't find this kind of people anywhere else, in the sense like a lot of people, a lot of my friends were like extremely unique. So and like they were like really like, I mean, it was a very good environment to be in, as well as to that uplifts us, as well as like a lot of what like we had like so much fun as well, right? Okay. So just to like start like how I got into ENTC. So the first semester, like I was like very good at programming, but I didn't like CSE much. So because I didn't want to just like, I mean, what just write code all the time. So, but I wanted something more than that. So like I joined ENTC. Like one of the reasons is that, and the other one is like the great people or the unique people I found like in other departments, they were all like choosing ENTC. So that was like one of the main reasons. So I didn't have any sort of a plan when I joined like our department. So it's like I didn't know what I was going to do, or like, I mean, it was so there are people who come up with who join the department with plan. So I think like probably Kanchana was like he was uh, award winner from our batch, and like he was what someone who had a plan. So in the sense he wanted to go to AI, and I think from the beginning he did a lot of research stuff like that. But in my case, at least my path, I didn't have a particular plan, so I was lost until semester five, right? So this is like a pretty common experience. So if you are feeling like that, then it's okay. And then like in semester five, like I designed my first processor. So this was like a semester project. And through that, I got very interested in digital design. So that is like designing digital circuits, designing chips, so stuff like that, doing the RTL design. So it's like logic design of chips. So I like got really, really interested in that. It was like so fascinating. And like, yeah. So that basically helped me choose the path. So then, like around the same time, I also had an internship in Australia. So I was there for like 6 months, and but the project of that was robotics and AI. So basically, embedded deployment of AI models, like on a moving robot, like a mobile platform. So and I learned a lot from there, as well as I made some very good connections. So it was a very nice experience. And then, so after that, when I came back in the last year, I focused on digital electronics. So I took many chip design courses, but I also took like robotics and some other courses as well. So basically, I didn't want to restrict myself too much. So, and that is another approach. So some people, they know that what they are going to do. So and they take all the courses and everything needed for that. They do research projects in needed to that, and by the time they graduate, they have like a lot of papers or like what a lot of experience in one area. And there are other people who want to learn a bit of everything, and that way like you can have like a very solid fundamentals in your undergrad. So I wanted something like that. So I did that. So I took a lot of digital courses, but also I took like robotics, AI, and some other courses as well. So then we had a final year project. So that was sort of it was like an interdisciplinary project. So basically we had traffic control, and then you have like computer vision, then you have digital electronics, and all of them together, right? So it was like a great experience working across the fields, and it was a pretty big project to handle for us, but then it was a very nice experience. So after that, like I wanted to teach. So and I enjoy teaching a lot. So I joined as a junior lecturer at the department, and so we had some good times. So this was during COVID. So then we had some challenges on adapting some courses to COVID. So we were doing those things. And within like a few months, I got an opportunity again through the department that like a Canadian startup. So they were designing chips for AI acceleration. So I got it through Dr. Chamira. He recommended my name. So that's how I joined that company. and it was a pretty good project. So like it was around the beginning of like economic crisis, so like just before the economic crisis. So and they were paying in dollars, so it was like a great opportunity back then, right? So and I worked there for like 1.5 years and got some pretty good experience and guidance. So and then I applied and I got accepted at UCSD, University of California, San Diego, and I'm working there. So over there, like I'll tell about my projects here. And then I also did my internships at Qualcomm and AMD, right? Again, like related to chip design stuff. All right. So some key takeaways from this sort of path is that one is it's okay to be lost. So if you feel lost at any point in time, or like I mean throughout the years, then it's completely okay, right? So the whole point of the undergraduate curriculum is to sort of like introduce you to different fields. So that way you can sort of like get a taste of everything, and then later on you can choose something, right? So it is to give like a some to help you learn in all the different fields. So it's okay to be lost. So take all the courses that you enjoy and do everything, right? So, and this one is basically you need to, I recommend you to put like your 110%. So basically you put your 100% and then maybe you go a bit extra into every single semester project, right? So you have, I think these are like really good opportunities to find your passion. So for an example, I found my passion by like designing my first processor. So I didn't even know what digital design was when joining the department, right? So this is something you find only after doing these courses. So don't just slack on the project. So like do the bare minimum stuff like that. Always work really hard on every project. Okay. So take your time, like maybe like find some good friends, and like even if your group mates are not working hard, like which is like a common problem. Even in that case, like you put all your effort and like into what every project, right? So that would help you a lot to find the passion, as well as it might help you in the future to connect with other things as well, right? So, and this one like is basically the biggest selling points of joining ENTC. I think it is a opportunity gold mine, right? So that is like probably the only place in Sri Lanka where you can get this much opportunity in one place, right? So, and that sort of started with, for me, like it started with my internships in Australia. So like, so the what I feel is the problem is like Sri Lankan universities in general. So we don't have like a very good name recognition in general outside Sri Lanka, right? So I mean, like if it is even India, like you have IITs and people know about IIT Bombay and stuff like that everywhere. But Sri Lankan universities, you don't have that name recognition. But what you have instead is like we have from ENTC, you have like so many seniors who have gone to different universities, different research institutes, and different companies, and they have worked very hard over there. So the people who have seen them working, so they know University of Moratuwa and they know ENTC. So and then they hire more students from ENTC. So that is how like we have this kind of threads going like in this kind of relationship with like so many different research institutes and companies or like universities, right? So this way you can easily get like research internship. I think like probably about 50-60% of our batch, they went on maybe like 40-50% went on foreign internships. So Singapore to Australia and like different countries, right? So you can get these kind of opportunities very easily. And but you have to be a little proactive. So you have to send a lot of CVs. You have to talk to professors. You have to do all that, right? So there's a lot of opportunity. Don't waste that, right? So like you have to be proactive and get those opportunities. And the other one is like so you may already know the structure, right? Like the first 1 or 2 years you have a lot of compulsory modules, and later on you have like a lot of elective modules. So the idea is like you over the time you sort of like find what are the things that are more interesting to you, and you take more and more of those. So that way, like at the end, you will have like taken a lot of modules in one particular area, right? So in my case, I took a lot of digital electronics modules. So finally, a project, I think like it's very important. So you have to pick wisely. So basically, pick something that will show your strengths later on, right? So a lot of people, like, I mean, if you want to, people want to go to like say software engineering or something, and like they choose something completely irrelevant. So I mean, you can still make it work, but then it's better if you choose something that matches your path. So that way, like you can use that as a stepping stone, and like you can basically use that to like get hired in companies, internships, everywhere, right? So this is pretty important. And then ENTC helps a lot to build a career. So as I said, again, like this opportunity, I got it through Dr. Chamira in our department. So how that worked is like, so Dr. Chamira has like a friend, and I think now he's a professor in UM as well, like a sort of like long distance professor. So he is Professor Arjuna Madanayaka, and he is in FIU in Florida. So they have published like a lot of papers, signal processing papers together. But then like there was in Canada, like they were starting a startup, like so, and then like they were hiring a team. So Dr. Professor Arjuna was hired in that team, and then like he asked Dr. Chamira to suggest somebody from ENTC, right? So that's how I got the opportunity. So you can see this global network, right? Canada, Florida, then like you have Sri Lanka, and then you have like Australia, like you have some what basically everywhere. So this global network is extremely valuable. So you can tap into it, and that is like that's what makes ENTC the gold mine of opportunities, right? So again, like in PhD, I was able to get because of all the projects I did and the stuff I learned, right? All right. So this was the third year process design. Okay, so basically, like this is one of the projects, and I think it has changed slightly now. Like you might have to design a RISC-V processor or something. So what we have to do is like we have to design an entire processor, a CPU from scratch, right? From you have to write. There's a language called Verilog where you write stuff, and like you can design circuits. You make these gates and multiplexers and everything, and it is so fun. It's like, I mean, it's like you are putting together, building Lego blocks, and you are making something to work. And you can actually put it on a FPGA board, and you can see it working. So we designed our own assembly language, and we built our own sort of compiler or assembler. And then we like built our own processor, and we wrote our own algorithms. You put it over there to do some processing. So this is our custom assembly language, and we have our compiler and a simulator in Python. And then like basically this is um, what we applied like sort of like an Instagram filter, right? So like this is our final year project team, right? It's Chintana, Rukshan, Teora. Yeah. So here Chintana is doing PhD in US, and Teora, like she did a master's in Canada, and now so Rukshan is working in Canada as well. So, and this project's the requirement was not like doing any of this. So it was basically like you have I think 256 image, and like 512 by 512 image, and you have to downsample it. You have to make it smaller, right? So, and which is like, I mean, pretty straightforward. And then it has to be like it's just a black and white image. So we went a bit extra. So we worked for like several months, and like we added a lot of features, and yeah, so that actually helped us a lot to learn like this field very well, and like it helped me a lot later on as well. So which is why I say like put your 110% in the semester projects. So because that they are going to help you a lot. So this is a fourth year project, like a bus design. So you have to build like on-chip bus. So on-chip bus means like inside your phone chip or your laptop chip. So you have your CPU cores, and then you have your memory cores, and then you have your GPU cores and all of that. So there is like a bus that connects all of these together. So how does your CPU talks to the GPU? So they're all in the same chips. So in the modern MacBooks and all. So how do they talk with each other? So like for that you need to have a system bus. So we need to design a system bus from scratch, and we have to design the protocol from scratch, and then you have to like we have three different groups. We design three different protocols, but you have to put them together, and then you have to move data between them. So it was a very fun project, and like we worked pretty hard for this, and this also helped me a lot. And I actually learned how to not build a bus, so which is very important. So because the projects that I'm doing now are about like bus design and bus verification, stuff like that. So it's a very fun project, and it was very useful for me as well later on. So this is our final year project. So the idea is basically now you have all these traffic signals in Sri Lanka, and these are like timed, right? So they have fixed timings. So the traffic engineers, they like count all the vehicles once in a while, maybe like once a year or once in many years. And based on the traffic pattern, they will come and change the signal lights. So once a year or once in many years. So this is not very sort of efficient. So then there are like in foreign in different countries, you have projects like you have cameras and you measure the traffic flow, and like based on that, can you change the timing dynamically, right? So that is something that we wanted to do. So this is like what we did. So basically, you have a camera, and the camera takes images like that, and then like you use object detection. So YOLO, like it was pretty new at the time. So then you use YOLO, and you do some object tracking, and like from the object tracking, you measure the traffic flow, and you from that you calculate the green times. So this had a lot of work, like in the sense we worked with traffic engineering software, we worked with training, like basically modifying YOLO and like basically training for Sri Lankan data set. So we added like a three-wheeler class, and you had like a like bicycle, motorbike class, and all of that. So yeah, and then we had to build like the hardware design, because we are putting this on FPGA and stuff like that as well. So this is the object detection tracking vehicles. So like it's a simple tracking algorithm that I wrote. So yeah, and this is the convolution engine. So that we implemented on FPGA. So this is like again like basically you can write all this what digital circuit in a language in called Verilog, and that way you can put it on a like a flexible chip called FPGA. So like if you before you actually tape out a chip, you can prototype that within this kind of a flexible chip, and then you can run it at like 200 megahertz or 400 megahertz, and then you can like look at the performance and stuff. So that's what we did. So this was like a really fun project, and this helped me to get my first job, and then it helped me to get my internships as well. So it was like really good. All right. So this is my PhD projects, what I'm doing right now. So this is basically, so you might have heard about Large Hadron Collider. So this is a like so in Switzerland, so in the France-Switzerland border, you have this CERN, right? So over there, like you have Large Hadron Collider. So that is the largest machine ever built on Earth. So it's like 27 kilometers wide, and it's like a tube, and that is buried underground. And you have like protons which are accelerated like at near light speed, and you collide the protons, and when they explode, you take photos, or like you have sensors that take photos, and then you see if you can find any new particles, right? So these people, they have a problem that is like when these protons collide, they generate like a lot of data. So you have like 320 terabytes in a second. So that is a lot of data, and you can't move all the data out of that sensor fast enough. So you have to do like a lot of filtering. So you have to discard a lot of data, and you have to choose which data is interesting, and you have to move it. So for that, they have like small neural networks, which they have implemented in chips inside that sensor. So then the question is like, can you, and they have some libraries to do that, but those libraries cannot handle like large networks, large neural networks. So like anything larger than like maybe like 10, 15 layers, right? So then like I basically worked on building a accelerator kind of architecture, and a small like a Python framework to like quantize a model and put it on that put it on that accelerator, as well as like an entire verification suite to verify this, and like some like flows to make it into ICs, or like make it into FPGAs, right? So it's like a top to bottom framework. So this is something I worked on, and yeah, so this is one project. The second one, what I'm doing right now, it's called hardware fuzzing guided by information flow tracking. So this is more of like a hardware security thing. So the problem is sort of like the chips can have like security vulnerabilities. So I think the most famous ones are like Spectre and Meltdown. You might have heard about them. So that is like 2, 3 years ago, like a research team, they found that literally like every laptop out there. So that in the sense, all the AMD and Intel laptops. So all of them have this problem of like you can trick the branch predictor inside the CPU, and that way, like you can basically read somebody's password or you can read sensitive information, stuff like that, right? So that was like a huge. I mean, before that, like hardware security was like a pretty niche field, and I think that news that hit like all the like news headlines and everything. And after that, like the companies are now more cautious and they are like sort of over spending some money on hardware security. So they want to validate their say, designs don't have any problems and all that. So how do you know, like, I mean, whether these problems are there or not? So one of these is called hardware fuzzing, where you send sort of like random inputs and see if you can crash or if you can get the CP, you get the hardware design stuck, right? And then if something achieves that, then like you want to try something new and like I mean try what more ways of doing it. So that's called fuzzing. And so the hardware fuzzing is pretty new. So we are building some IPs to do that and some entire frameworks that can automate it and stuff like that. So this XA protocol, this is what I work with a lot. So this is a bus protocol that is in all your phones, all your laptops, Apple laptops, and all of them. So there's like a language talk, like which the subsystems in your chips can talk. So it's a pretty cool project. So it's what we are working on right now. And some challenges like you might face in ENTC, right? So one is like the ENTC courses can be very math heavy, right? So some modules can be pretty abstract. So for an example, if you take random processors or like yeah, random signals. So all of these like these are like extremely math heavy. Like we have like double, triple integration and all of that, right? But it is like so. I mean, it was so amazing. So and in my case, I was not great at math. So during AL, I was very good at physics, but not very extremely good at math. So even after A levels, I wanted to sort of keep my edge. So I gave like tuition classes, so like personal classes, like once or twice a week, and so that was actually a very good way to. And in the classes, I just go there, I just sit down, and so there was this girl, and like she does past papers, and anything that she can't do, like she basically gives to me, and so I sit there and just solve AL past paper questions, right? Integration, like applied maths, and like everything. So that actually keeps your brain sharp. So you can do something like that, right? So, and the second one is like, I personally feel CSE is sort of better for software engineering. So that is, if you want to get into software engineering, then like CSE might give you better guidance. But a lot of people go through ENTC as well, right? But I feel like ENTC has a lot more to offer than just software engineering. So you have like what all this hard digital design, you have like a lot of other stuff. Right. So I ask you to explore those things than just going to software engineering. Yeah. But it's definitely worth it because you get this ton of global opportunities and you get these amazing people. So very unique people who have like very unique hobbies and like very unique sense of humor, right? So that's what I found like in the first semester. So like you have all these kind of very unique people. Like I mean, probably the more all the unique people in Sri Lanka like might have ended up in ENTC, right? Which is pretty rare, right? I don't know whether it's the same case in the following batches, but at least in my case, batch it was like that. So the other one is like the positive peer pressure. So this is very important. So because I am not like super self-motivated, so it was very good for me that like other people around me were like studying very hard. So they were like sort of pushing me upwards, right? So there's always this, I mean, just before every exam, people spend the 3 weeks, 3, 4 weeks very seriously studying for exams. And then you have a lot of like cookie classes and like people do past papers, share in the group. Okay, so there was like a very good academic environment where like each other is like what influencing you to study more, right? So I think like in some departments or some universities and some places, like they don't do that. They actually do the opposite. So that is if someone is studying, they are like social outcast, right? So in ENTC, that's opposite. Like it's what whoever studies, that's a norm, right? So that's a very good thing, and that lets you that encourages you to achieve great things. And then you can get hardware jobs, software jobs, higher studies, startups. You can basically get like the whole spectrum, right? So I think like most of the startups from in Sri Lanka, like successful ones, are from ENTC. So, in the sense like people who what like either the founders or the ones who joined afterwards. Yeah. So it's really great environment to for that as well. And then like the teaching and syllabus is like really good. Like at least like in my time it was good, and I think later on it is even better because while I was a staff member, junior staff member, we had this syllabus reform, right? And they took our input as well. They took students' inputs, so like it was a massive reform. So I think like it's even better now, right? So yeah, and then you have like a large global network of alumni, so who you can reach out to if you want any help. So even today, I think I left like Moratuwa when 2019, so that is like 5 years ago. Yeah. So 5 years ago. So and even after 5 years, like I still get messages from random students like all the time. So saying, can you like suggest me this? Can you like I want to do this project. Can you advise me on that? Stuff like that. And I reply to all of them, and I help with them as well. So this way, like I mean, you have a huge global network. You can reach out to anybody. You can message them in on LinkedIn. You can just if you find the phone number, email. So you can, yeah, they will help you in any way they can. Okay, so this is a huge opportunity. So another question is like, is ENTC sort of too heavy? So not really. So like in my case, I watch like so many movies, so many TV series. Like pretty much every week, I watch like 2, 3 movies and like over TV series episodes and all that. So I hiked, I camped, and I travel like almost every month. So, and we had a very good hiking and camping team. So we used to go on like on random times, like suddenly we plan and like we go in every weekend, every once of the weekend or stuff like that. And we traveled throughout Colombo, like basically like we roam around Colombo on random nights. So yeah, and I went to India for 2 weeks. So before FIP Viva. So and then I still got like a GPA of 3.92 out of 4.2. So and my friends, so I have a friend like who was a twice captain of the badminton team, that is Moratuwa badminton team, and what so she was basically like leading the team to victory in like many like national competitions while doing all her what studies and maintaining her GPA, right? And she had like really fun hobbies, she very unique hobbies and all, and I'm very good friend with the family as well. And now she is doing her higher studies in Finland. And then I was like I had a friend who was a rowing captain, and he did a lot of research as an undergrad. He did a lot of clubs, and he also won gold medal, right? So you have like a lot of people like this, so which means you can do everything, right? So it's not too heavy. So you have like a bunch of fields: analog electronics, digital electronics, embedded systems, robotics, okay, signal processing, machine vision. So you can basically like learn a bit of everything. Okay. So that way, like you can easily go through, right? So that way you can find your passion. That is sort of my takeaway. So this is analog electronics. That is Kidman's project on micro mouse. So micro mouse is like highly optimized, very fast moving robot. Okay, and so you have to like super optimize this PCB design and like all the signal integrity. So you have to, it's like a lot of work, right? So Kidman built this like in his final couple of years or something. And digital electronics. So this is like IC design. So this is inside a chip, one of the chips that we built. I think as a final year project, final last semester project or something. So, and then you have, this is the FPGAs. So that is like putting the similar design on these flexible chips, right? So you have all of that. And then like embedded systems. So you have all these different, that's like its field of its own. You have like, you get different projects on it. Robotics. So robotics is like massive in the sense like you have, either you can work on electronic side or you can work on algorithm side. Okay, so it's very on the algorithm side, you can even go very abstract and very math heavy. So for an example, all the self-driving robots, they use like Bayesian filtering, right? So I learned a bit about it. It's so fascinating, right? Like how do you so how do you take all these different probabilities, different errors from all the different sensors, and how do you put everything together to find your location, right? So like ABC. So for an example, initially you get this data, and you're like what your guess is like pretty random, right? And with a little more data, when you start moving, you get a little bit more data, and you merge all the data from your motors and from all your sensors, and from that you can pinpoint like location of objects as well as location of yourself more and more accurately as time goes. So this is like really fascinating area on the algorithm side. And on the like actual like say electronic side also, it's pretty interesting. So in the sense what you have to how do you deal with motors and like their powers and all of that, right? It's a and then yeah, so it's like a very math heavy and like a very interesting robotics. So and then you have like a lot of robot competitions and like all of that going on. So I urge you to, even if you don't like robotics, just take part in the robot competition. You will learn like a lot of things, right? So do that. So this is like a quadruped robot from my friend Iresh and Samit and all, I think. Yeah. So that is basically what a quadruped robot helps you to walk on like uneven terrain and all that. So this is signal processing. So, and this is like an extremely math heavy field, but it's fascinating. So when I did the actual signal processing courses, I didn't understand anything. So it was like because it was so heavy. And but then like later on, like when I became a junior staff member, like I was asked to TA for this course. So and then I sat down and I learned a lot about myself, a lot myself, and then I taught them like in multiple lectures, and it was amazing. Like I mean, what they loved basically all the concepts, and it was yeah, it's so beautiful. It's such a nice field, and you have like a lot of people publishing in signal processing in top tier conferences almost every year. So Dr. Chamira, he's very good at like guiding people into these conferences and into publishing. And you have Daru right now, like he's doing in USC, and so you have like a lot of people who like from this area working in and publishing around the world as well. So yeah, and this is machine vision. So and our ENTC is like very well known for this. So Dr. Ranga, he leads the effort on this. So you have this is Moho Afam's paper, and then you have I think like from this time you have like a lot more papers after that as well, all in top tier conferences every year. So if you want to get into these things, don't wait for the last year. Just like in the very first year, just talk to Dr. Anga, Dr. Shamira. They are very helpful. So what talk to them, and they will get you into some small project. So from there, you gradually like you start working on bigger projects, working with your seniors, and that way you can finally like by the final year or something, you can get like a top tier publication. So it's a very good way of doing it. So this is Ashwin's project and Ashwin Kidman's project. Yeah. So wearable sensors. So Ashwin is now in John Hopkins University doing his PhD. So this was like a very intense project. They did so much work. So they had to develop custom sensors and like a bunch of like different stuff. Yeah. So this is some elephant collar. So Tamidu this project and this is on IoT devices and stuff. So if you are more into say like social problems you want to solve, you have to help like you want your help to be tangible, like you want to help people in Sri Lanka, stuff like that. You can still like you have a lot of opportunities where you can do this kind of projects, right? So you have like the entire whatever you want to do, ENTC has to offer. Okay. So you just have to like ask. So that is sort of the whole idea. So you get like a job opportunities in all these areas. So and I recommend you to basically yeah. So some further tips. So the GPA is very important, right? So but then it also it is not very hard to maintain, right? So I feel like I mean if you are getting A plus in every single module, it's like it takes a lot of work, right? So and I think like I know one or two people who actually did that. So they got like a what almost 4.2 and almost 4.2. I can't remember. So they did that, and that is very hard to maintain. And a lot of people do that still, and that is extremely impressive. Okay, and if you can do it and you want to do it, you do it. Okay. But then if you are like me, okay, who don't want to work that hard, okay, so I feel like you can easily get like a mix of A's and A pluses and like maybe one or two A minuses and all of that. And you can still keep like a pretty good GPA without like too much effort. In the sense, you still have to understand all the material, you have to do past papers and stuff. But then, like, I mean, without like 100, I mean, you can still go on trips and you can enjoy and you can do all that and you can still keep like a very good GPS. So this is like a big advice to everybody. That is like make a blog, right? So you create a blog and you in the blog you write one post each per your project. For every project you do, you make a post, and in that post you basically you don't write about random stuff about all the background and introduction all of that. You write the problems that you faced and you fixed, right? You particularly individually. So what are the problems you faced and you fixed? So and that then you link that each post to your CV. So and this will help you to get jobs and internships a lot. So I got this advice again from a senior, right? Again, like that's a opportunity gold mine, right? So in Shafaya, he gave me this advice, and that helped me a lot, like throughout my life. So please do this, okay, everyone, and attend lectures. Okay, just go there and just sit there. Don't cut classes. So, but now with the Zoom and everything, it's too easy to cut classes. Just go to the lecture, sit there. You don't have to pay attention. Okay, you don't have to listen. Okay, maybe like I mean, don't be on your phone, but you just sit there and like maybe just scribble on your note or something. So just being there will help you a lot, and don't get completely lost. So that is a huge problem. So people like don't attend lectures and get lost. Don't do that. So you can have an idea of like what is going on in the module throughout the semester. So first you study the material, then do the past papers. That's pretty important. Reach out to lecturers, reach out to professors, very important. And don't always trust seniors, right? So some people take like everything the seniors say as gospel. Don't do that. Okay, just take it with a grain of salt. And yeah, so always reach out to the lecturers, like trust lecturers and trust your staff members more than the seniors. Okay, they are there to help you. All right. So join clubs and you find friends outside your district. So this is a big thing. So when I was there in Maratua, this district thing is a huge issue. Like everyone is like stuck with their own district. Don't be like that. Have like a what have friends from all over Sri Lanka. So that will make your life much richer. And yeah, if you are like me, just travel a lot, enjoy a lot, and never ever give up. All right. Right. Thank you. Thank you so much. So I hope I didn't take too much of your time. Right. Thank you.
Thank you very much, Abha. We can
Sure.
take one or two questions. Yeah.
Of course. So if you have any questions, you can ask me. Yeah.
Yeah. So can you talk about your teaching work, the teaching work that you did the missing semester
Oh,
and
yes,
so?
yes, yes, sir. I forgot about that. Yeah. So basically, like, yeah. So what, so I, during COVID, like, I was basically going through some material from MIT. So MIT has this missing semester. So that I got the name from them. It's not something I invented. So they have something called missing semester where they teach about the Git and they about like how to use Bash and make files and stuff like that. So these are like a lot of technical stuff, which I mean, obviously you don't learn in the class, right? So you don't have a class on how to write a make file, right? But it's very important if you want to do a project or something, right? So these things they teach it. So then I like I took the idea, but then like I didn't want to just teach those things. So the first course I prepared was like the system verilog course. So like it's like a usual pattern. Like they don't actually teach you a language completely. So they will teach you some constructs, and they expect you to sort of learn like as you build the project. So that's how it should be. But then what I found at the end, like when grading students' papers and everything, was that the code the hardware code, hardware design that they write. is like they write hardware design just like software code, right? So that leads to like very inefficient hardware. So then, like, I mean, I read a couple of books on that topic, and then like I wanted to share that knowledge. So I made some slides, and I did my first session in 2020 as a free session, and you can get the slides and everything from my blog as well. So, and that was like pretty good. And I think about 300 people joined, like from different countries, from Sweden, India, and all, and some of them from Sweden, India, and all. So, and that was like very valuable. Then later on, like we did some similar thing about for robotics, and then for some embedded systems. So, and then these were with Kidmin. So Kidmin joined after that. And then later on, we Dr. Subodha, like he joined with us, and then like we sort of started it as a startup and started offering these courses and some more advanced courses because, like, I mean, we don't have the bandwidth to develop all the materials so ourselves. So then, and those are also going pretty well. So, and these are like some things you can do in the sense like the stuff you learn, you can go and teach, right? So, and during my undergrad, like I actually went around and taught robotics in like a lot of schools. So, like, and in one or two schools, they actually started robotics clubs after that. So, one school in Kandy and one school somewhere in Anuradhapura. So they were like very passionate, and they had all the items, like in the sense, so they had a lab and everything, but they didn't have the knowledge. So, and then like we talked a lot, and like I mean, we sent even more people from our department to help them out. So that was like a very good initiative. So we recommend you to do these kind of things. So you can spread this knowledge like to other people. And if you learn anything, if you find anything valuable, say you do a robotics project and you understand stuff. And if you're good at teaching, if you enjoy teaching, like I mean, feel free to make like a YouTube video or like I mean, do anything, right? So that would again that would help. That would look very good on your resume as well as like it will help a lot of people also, right? And even like even now as part of these courses we do these free information sessions. So that is like the first session is like a free session. So we introduce a field, so like say a chip design. So like I mean what is inside a chip, and like basically what are the steps and what are the areas in there. So this kind of knowledge is something that I didn't have when I joined the department. So you don't even know that this field exists, right? Or how do you get into this field? So spreading this kind of knowledge is like I think extremely important for like everyone.
Thank you so very much, Abba.
Yeah.
If you have any question, we can take. Otherwise, we can conclude. Thank you so very much. It was so informative. I think you will
Sure.
be sharing the video also. And
Okay. Thank you, sir. Thank you so much.
there's a person.
On behalf of everyone, I would like to express our sincere gratitude to Mr. Abarajithan Gnasenswaran for taking your time to share such valuable insights about your journey at ENTC. Since we just started our journey here, listening to your speech gave us an idea about how we should proceed in this journey. I once again thank you for your time and guidance. Thank you.
Sure. Thank you. Thank you so much. You can reach out to me through email or something, like whenever you want. If you have any questions, or if you want to know about how to, like, I mean, any field, especially about hardware design, chip design field. So that'll be great. All right.
Yeah, thank you so very much.
Thank you.
Have a
Thank you,
pleasant
sir.
evening.
All right. Sure, sir. Definitely. Bye.